As I mentioned at the end of that last video, the other way that we can talk about a quadratic, the other way we will talk about a quadratic here anyway, is in terms of what's called the general form equation. The general form function, I guess we'd say in this case, f of x equals ax squared plus bx plus c. We did see a little bit like that earlier, where in this case we want to look at the vertex. Again, a very important value, even though this form isn't quite as indicative of where it lives, would be at the point negative b over 2a, f of negative b over 2a, where for this, the value a kind of tells you a lot of the same things that it did in the standard or vertex form, where it's also a bit of a horizontal stretch factor for the general behavior of the function. The b value is something like a horizontal shift, moving to the left and right with a bit of a half factoring in there, and then c gives us the y-intercept and is thus a bit like a vertical shifting term, where the process that we can follow if we want to graph something using the general form is actually very much the same, except finding the vertex requires a tiny bit more algebra, as it's not explicitly given in the expression of the function. But we'll see what that looks like with an example here. So for this example, we want to graph the function f of x equals negative x squared plus 4x plus 1. And from here, just like last time, getting the value a is very important. So we have a is equal to negative 1 here, where I swear there are quadratics where a is not equal to negative 1. It just happens that these are the examples I have. And then b is important for us. That's equal to 4 here. And the reason why it's important is because if you want to get the vertex, well, it's not just given by the statement of the formula like it was with the vertex form, for hopefully obvious reasons. So we have to use the formula here, negative b over 2a, f of negative b over 2a, which in this case would have the flavor 4 over 2 times negative 1 with a negative in front of it, and f of negative 4 over 2 times negative 1. So a whole lot of negatives in here. We'd end up just having 2 f of 2, or plugging that in there to our function, we would have 2 squared with a negative would be negative 4, plus 2 times 4 would be 8, so you'd end up with positive 4 plus 1, and you get that the vertex is at the point 2,5. Then, we want to be able to describe the roots, but unfortunately here, looking at that thing, you can't quite factor very much usefully with a 1 and a negative 1, certainly not anything that can get you 4, so you'd be stuck using the quadratic formula here. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, which in this case has the form negative negative 1 plus or minus the square root of 4 squared minus 4 times 1 times negative 1 over negative 2, which is negative 4 plus or minus root 20 over negative 2. You can simplify that down if you really want to negative 2 plus or minus the square root of 10. But most usefully, we would get from this thing that we have the values x is approximately 0.2 and 4.2. Where if we want to deal with the y-intercept, for the y-intercept, we would end up having, well, y is equal to f of 0, so that'd be negative 0 squared plus 4 times 0, not a whole lot doing yet, plus 1, so you get y is equal to 1, and if we want to graph this, we'd have our intercepts at roughly 0.20 and 4.20 along with 0, 1, and the vertex at 2,5, so we'd end up with something tracing those points out a bit like this. And if we want to describe the domain like we do last time, we have that coming up, that opening downward, parabola there. So our domain would again be negative infinity to infinity. Our range would be from negative infinity to 5, including 5. And because the x-coordinate of the vertex is 2, we would have that symmetry along the vertical line x equals 2. And the next thing we can look at here is just a bit more about how we can describe some potential behaviors, in particular behaviors with regards to extreme values and that vertex.